Before we reveal the answers you guys selected here, I wanted to go over some good math communication here with you, okay? So this is an inequality. I know it's an inequality because it has an inequality in it. And we're going to isolate the variable just like we did with an equation. So to go about that, what should my first move be, Will?
Your first move should be... It already gives us the first step.
Yeah, I kind of blanked it out so we could just do it.
Oh, okay. Well, you should subtract 9 from 9.
So I'm subtracting 9.
9 from
1. Alright, and that would leave me with negative 2x is greater than negative 50.
And then you should divide them both by negative 2.
Okay.
But because you're dividing by a negative,
He remembers. So because we divided by a negative, everything becomes its opposite. Big things become really small things, small things become big things, right? So x needs to be less than 25. Let's fill it in. Cool. Thanks, Will. So this is like the communication you need to show. Notice it's exactly like the communication we did for solving equations, right? Like actually not any different at all. Let's check our answer. So what's a number that's nice to work with that's less than 25?
10. 4.
10. Those are all right.
Negative 11.
I'm going to go with 0.
Okay.
Well, because if I plug in 0 here, it says 9 is greater than negative 41. True? True. So I checked my answer. It works. Cool, guys. All right. So we had that inequality. X is less than 25. So on the number line, which you guys selected, this is 25. Open or closed?
Open, because it doesn't include...
Yeah, open. 25 doesn't work. Less than is anything to the left. A la izquierda.
Yeah, anything behind...
There we go. All right, Joe, read me that original problem again.
So it's negative 3, and then in parentheses, 2x plus 4 is less than negative 3.
That's it. Okay, so there's actually going to be 2 ways to go about this one. The way that Desmos was guiding you toward was distribution, right? So with distribution, we'd have negative 6x minus 12 is less than negative 24. Amelia, what would be next? So remember, we're undoing, so it's the reverse order of operations. So my options here are multiply or subtract. Yeah, so we're going to undo minus 12 by plus 1, yeah. So we're going to add 12 to both sides. So negative 6x is less than negative 12. And last step, Caitlin, what am I going to do next? Okay. Thank you. But since I divided by a negative,
flip the symbol.
there we go. Thank you. So x is greater than 2. That's what everybody that finished it on the Desmos said. Now I want to show you something cool. There's another way. And this is actually the way like I personally do it. From the starting equation here, I like to divide both sides by negative 3 first. You guys seeing that? Could do that. That'd give me a 2x plus 4 is greater than 8. Subtract 4. 2x greater than 4. Divide by 2 for x is greater than 2. What do you notice about my answer?
It's the same.
Yeah, so I can undo that multiplication.
You can do it 2 different ways.
Yep, because math is creative, right? So I could
Math is
distribute, and in fact, some of you guys distribute in times where it is not the most efficient. Like, I have students who, believe it or not, and I mean, it's not wrong to do this, but you'll do something like, if it's like this, you'll distribute and then add instead of just add and multiply, right? You guys see what I'm saying? I'll have people that'll do 15 plus 9, maybe want to do 15 plus 9. I would do 8 times 3 myself. You know, I would just do what's in here first. The reason we distribute a lot of times when there's a variable is because that's the only way we can get rid of the parentheses, if we need to get rid of parentheses. So if I had something like this a couple times in an inequality, I probably would need to distribute unless I had the same number out front or something maybe. But so there's times where distribution is actually like easier. This time it's probably about the same. Sometimes distribution is easier, sometimes it's harder. So again, like I say, a lot of the stuff we do is like tools for the tool belt. I want you to have the skills to be able to use the best thing in each situation. So let's check out the graph to that.
Where would make the sound?
If x is greater than 2 friends, does 2 work? Does 2 work?
2 doesn't work. No,
2 doesn't work.
It's not equal to
Greater than 2, so right. This is Batman colors. Why haven't I been doing this?
That's amazing.
Yeah, dude. All right.
Negative, and then x over 2,
Mm-hmm.
and then plus 12,
Okay.
and then that's greater than or equal to negative 4.
Awesome. What's the first step?
So the first step is to subtract 18 from both sides.
I thought you said it was 12.
Oh wait, oh crap.
Is it 12?
That's a different problem, my bad.
Okay. Psych.
We can't see if we got it right.
Is that
Nathan, which one did you want to look at?
Wait, can you just see the little
I'm just
thing
going back to the page.
for a second?
Is it 8? Can someone else see 8 right now on there?
Oh yeah, I can see number 8. So it's negative x
Oh, here we go.
over 2
Okay.
Yeah,
plus
that's it.
12
Okay.
is greater than or equal to negative 4.
Okay. Yeah. So what am I doing to both sides?
Subtracting 12.
There we go.
Yeah, that's not the wrong problem.
So negative x halves is greater than or equal to negative 16. And then watch this. This one might be counterintuitive, but I'm going to multiply both sides by negative 2. Here's why. A negative times a negative is a
Positive.
positive, so that leaves me with an x. Everything's becoming its opposite, so I need to flip my symbol. So x has to be less than or equal to 32. So on your number line, 32 works, and so does anything to the left. Now, my favorite point to test here is 0, because when I put 0 here, it's gone, right? So if I put 0 there, I'm left with 12 is greater than or equal to negative 4. Is that true? Yeah, so it checks out. An answer from my graph checks out. Cool, cool. What other one? One more. 8, 9, or 10 maybe. Jump. Rate it to me.
Number 7.
Okay, we can do 7. Rate it.
Okay. Negative 3x minus 19 is greater than or equal to negative 5x minus 53.
Okay, so we have a variable on both sides. So if our goal is a variable on one side, we need to get rid of one of these. The first step we might consider doing is combining like terms, but all like terms are combined. So my first move here, Joe, is adding 5x to both sides. Because I'll just get rid of that. Now I'm going to be left with one term of x. You good with that? And then just like Nathan's last question, I got 2 steps. I'm going to add 19 to both sides. And that's going to give me negative 34. 50, yeah. Divide both sides by 2. Am I going to flip my sign?
No.
Nope. You know why I'm not flipping my sign? Because I divided by a 2. So everything's cut in half. Does not change the relationship between positive and negative, right? So on my graph, does negative 17 work?
Yes.
It works. And so does everything bigger. So something bigger than negative 17 that's nice to work with is 0. And if I put 0 in here, is negative 19 greater than or equal to negative 53?
Yes.
It is. So that's good. 0 works. Cool.